Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss some problem based on variation of parameters. In last lecture, we have discussed about the method how we can apply variation of parameter in a linear differential equation of second order with constant coefficient. So in detail we have discussed about this method, how we can apply in a differential equation, which formulae we apply in this method. So we have derived all formulae which are used in this method in last lecture. But now today in this lecture, I want to solve problem based on method variation of parameter. Topic is, in this lecture, our topic is problems based on variation of parameter to solve linear differential equation of second order with constant coefficient. Today I want to discuss about the topic problems based on variation of parameters. This is very interesting method to solve any linear differential equation of second order with constant coefficient. We can solve a linear differential equation of second order with constant coefficient easily with the help of method of variation of parameter. So type of general linear differential equation of second order with constant coefficient is given as below. Here I am writing equation 1. This is the differential equation of second order with constant coefficient. How we can say that this is constant coefficient? Coefficient means multiply. Constants means number. If numbers are multiplied with differential coefficient in each term to the left hand side, then differential equation is known as a constant coefficient. So here a multiply with second order derivative in first term, d2y over dx2, this is the second order derivative, and a is number is multiplied with this second order derivative. And in second term, this is the first order derivative, and v is any number which is multiplied with first order derivative in second term, and plus c is number multiplied with y is dependent variable. This is the left hand side. What in right hand side? There is some function x. X is the function of x. X is the function of x here. Okay, x is some function. This is capital X. Capital X is some function of small x. Small x is independent variable. Here a, b, c are function of x. A, b, c are number. Sorry, a, b, c are number. A, B, C are number here, constants, because we are taking linear differential equation with constant coefficient. So here A, B, C are number, are constant. A, B, C are constants, and x is also function of x, right? Here is not function. I am taking only constant coefficient. Our given equation, differential equation, is second order with constant coefficient. So A, B, C are number here. A, B, C are not function. So A, B, C always be a number which are multiply in each term with derivative. A multiply with second order derivative in first term, plus B multiply in first order derivative in second term, and C multiply in third in only dependent variable in last term third. And right hand side is some function of x. Say x. Capital X is some function of fx. Some function of x. F of x. So x is independent variable here, and y is dependent variable on x. Okay, basically this is the definition of general linear differential equation of second order with constant coefficient. Now, d over dx represented by capital D. D is the differentiation operator, and d over dx, this is represented by capital D. D over dx means differentiating with respect to x. This is represented by capital D. Capital D is differentiation operator with respect to x, where x is independent variable. Independent variable. Okay. Now, one time we define our differential equation, which we are using in variation of parameter. So, definition of linear differential equation of second order with constant coefficient. We are taking only constant coefficient, not variable coefficient. Definition of a linear differential equation of second order with constant coefficient. So, just I am telling in last slide, same I am saying here, number A number, A be any number, multiply with second order derivative of the differential equation in first term. A be any number, which is multiply by second order differential coefficient in first term of the differential equation. And P number multiply with first differential coefficient in second term of the differential equation. And C is number is also multiply with dependent variable y in third term of the differential equation. And RHS is x is the sum function of x. Here y is also function of x, say is y equal to fx. Y is also function of x and capital X is also function of x. And A, B, C are number. A, B, C are number. Okay. So this type of differential equation known as a linear differential equation of second order with constant coefficient. So in this equation, we apply method variation of parameter. How we can solve a linear differential equation of second order with constant coefficient with the help of variation parameter. So this is very interesting method, very easy method, which we are using here in some problems. Here we will apply method of variation of parameters and procedure how to solve a given problem based on general type of linear differential equation of second order with constant coefficient. Here I am taking equation 1. Some method we are discussing here very lightly we are discussing about the method. Then we solve a problem. What we are applying these steps in to solve our question. So I am discussing about the step. We have already discussed in method detail, but before solving the problem, I am also again explain about these steps. Then same steps we apply in our problem to solve given problem. So here ABC are numbers and x is the function of x. Equation 1 can be solved with the help of following method. This equation 1 is known as a differential equation, linear differential equation of second order with constant coefficient. So this equation 1 can be solved with the help of following method. Method is variation of parameter. So finding CF of 1. First of all, any problem is given to me, we find out the CF complementary function. First, anyway, we find out the complementary function of given problem. So if we find out the complementary function of given problem, then we putting right hand side equal to 0. This is very compulsory to be putting right hand side be 0. If we are not putting right hand side equal to 0, then we cannot find the complementary function. Okay. For finding complementary function, right hand side must be 0. So if right hand side is given in our problem, then we are taking right hand side equal to 0 first. So here I am putting here the equation 2. In equation 2, putting right hand side equal to 0. Right hand side is x x taking equal to 0. After putting x equal to 0, then we get this here. Putting here, finding CF of 1, putting RHS equal to 0. Then in 1, then we get equation 2. After putting RHS 0, then equation 1 convert in equation 2. So we get equation 2. Now, anyway, we find out the complementary function of 2. So here is step 1. Step 1, now we are considering here finding complementary function of given equation 2 is CF C1y1 plus C2y2. This equation 3, C1y1 plus C2y2. C1 and C2 are arbitrary constants and y1, y2 are two solutions of given equation 2. y1 and y2 are two solutions of equation 2 and C1 and C2 are arbitrary constants of equation 2. So y1, y2 are two solutions of equation 2 means y1, y2 verify to equation 2. So now after verifying to equation 2 with the help of y1 and y2. So putting y equal to y1, here putting y equal to y1. So this a d2y over dx2, putting y equal to y1 here, y equal to y1 and y1. So here 2 time differential of y1, this is y double dash, y1 double dash, a y1 double dash plus b y1 dash plus cy equal to 0, we get equation 5. This result must be 0. First solution verify to the given equation 2. Next, putting y equal to y2 into y equal to y2 into putting y equal to y2 into, then we get this. This is the y, value of y is y2. This is also y. This is y. Then we get equation this y2, this y2 and this y2. So this is 0. This equation 7. 2 time differential of y2 with respect to x, then y2 double dash. 1 time of differential of y2 with respect to x, y2 dash. This is dash, this is double dash. This is no differential. So cy2 equal to 0. This equation 7. This is step 1. Step 1. What is in step 1? Step 1 we find out the complementary function first. So we find out the complementary function, we putting right hand side equal to 0 in equation 1. After putting right hand side equal to 0, we get equation 2. Now we considering the complementary function C1 y1 plus C2 y2. C1 and C2 are arbitrary constant. Y1 and y2 are two solutions of equation 2. Y1, y2 are two solutions of equation 2. So y1 and y2 verify to equation 2. So now we are verifying with the solution y1 and y2 to equation 2. Means putting y equal to y1 first time, next time putting y equal to y2. Then we get two equations which are equal to 0. A y1 double dash plus b y1 dash plus c y1 equal to 0. This result must be 0. Next result a y2 double dash plus b y2 single dash plus c y2 equal to 0. This is next result. Okay. Now step 2. What is step 2? Finding particular integral. After finding complementary function, finding particular integral. How we can find pi of 1? This is not pi 2. This is pi of 1. So pi of 1 u by 1 plus b by 2. How we can get this result? Means putting c1 equal to u in complementary function. C1 equal to u and C2 equal to v in complementary function of equation 2. Then we get pi, where u and v are function of x. And y1 and y2 are two solutions. And y1, y2 are two solutions. Okay. Now step 3. What is step 3? Finding value of u and v with the help of the following formula. This is the formula for u. U equal to integration minus x y2 by 1 y2 dash minus y2 y1 dash. This is equation 8. Next formula. This is the formula for b. B apply formula this for finding b. So b is equal to y1x. This is positive, that is negative. y1x, y1 y2 dash minus y2 y1 dash. In both formula, denominator is same. Formula for applying u and formula also applying for v. In both formula, denominator is same. One numerator is changed. What is change in numerator? In u minus x y2. In u we are taking second solution. In v we are taking first solution. In u taking minus sign and b taking plus sign. Okay? And denominator is same. y1 y2 dash minus y2 y1 dash. This is in denominator. So these two formula we are applying for finding u. Okay? After finding u and v, then we find complete pi. After finding complete pi, then we get complete solution of 1 y is equal to cf plus pi. Complementary function and particular integral, after adding we get by. This is the solution of 1. This is the solution of 1. Okay? So these methods basically we are using to solve any problem with the help of method of variation of parameters. So here we want to solve problem 1. Problem 1 based on the method of variation of parameters to solve linear differential equation with constant coefficient. So here one problem given to me in our question paper. Solve d2y over dx2 minus y equal to 2 upon 1 plus e to the power x. Okay. d2y over dx2 minus y equal to 2 upon 1 plus e to the power x. So this result, this comparison here, a d2y over dx2 and plus b dy over dx and plus cy equal to x. This is general equation. So after comparing here, a is 1, v is 0 and c is minus 1. C is minus 1 and x is 2 upon 1 plus e to the power x. Basically a, b, c and x, we are finding this. After comparison, this is this equation and this. This problem is differential equation of second order with constant coefficient. Now solution. Start to solve the given question. Again we are writing here question this. This is equation 1. d2y over dx2 minus y is equal to 2 upon 1 plus e to the power x. Equation 1 can be written as, we can write equation 1 in this form. d square minus 1y equal to this. This is equation 2. In equation 1, this is differentiation form. And now this is operator, differentiation operator form, D form. This equation is, this is in D form. D form. D is operator, differentiating with respect to x operator D. So differentiating operator form. So I am writing here. Now equation 1 is given. Equation 1 can be written as equation 2 after writing in D form. So now finding complementary function of 1. Here this equation 2 is question. So we can find easily complementary function of 2. Now finding complementary function of 2, putting RHS equal to 0 in 2. Then we get. This is d square minus 1 by equal to 0. Here putting x equal to 0. X is 2 upon 1 plus e to the power x. This is taking 0. This result putting in 2. Okay. Then we get d square minus 1y equal to 0. This is equation 3. Now finding auxiliary form of 3. Putting d equal to m and y removing from 3. Then we get here d equal to m by removing from 3. Then we get m square minus 1 equal to 0. This is equation 4. M square equal to 1. This taking this side. This is 5 equation. M equal to plus minus 1 after factorizing this. Factorizing like this, m square minus 1 equal to 0. So m plus 1 and m minus 1. This is factor. So m plus 1 equal to 0 means m is minus 1, and m minus 1 equal to 0 means m is plus 1. Okay. So here m is plus 1 and m is minus 1. This has different roots. Auxiliary form have different roots. M is 1 and minus 1. Two roots. So step 1. Step 1 now, CF of 1, CF of 2, not 1. CF of 2 if roots are different. Now applying following formula to finding complementary function. We have discussed about this formula in last lecture in detail. We have already proved this formula. So now complementary function is C1 e to the power m1x, C plus C2 e to the power m2x, where m equal to m1 and m2 are roots. m1 and m2 are two roots. m1 is 1 and m2 is minus 1. So there are two roots are this. So apply value of m1 is 1 and m2 is minus 1. Then CF is C1 e to the power x plus C2 e to the power minus x. But we have already considered here in formula complementary function C1y1 plus C2y2. This is formula. This is result. Comparing in this equation 8, comparing in equation 8 on both sides, then we get y1 is e to the power x and y2 e to the power minus x. We can find value of y1 and y2. This solution verify to equation 3. This solution verify to equation 3, whose right hand side is 0, because these are the solution of equation 3. So differentiating with respect to x, equation 9 on both sides we get. So now we get here y1 dash differential of y with y1 with respect to x. So y1 is e to the power x. So differential this, y1 dash is e to the power x. Differential of e to the power x is e to the power x. Differential of y1 dash is y1. So this is y1 dash is this is e to the power x. Next is y2 dash. Differential y2 is e to the power minus x. So d over dx of y2 is equal to d over dx of e to the power minus x. So this is minus e to the power minus x. This is y2 dash. So y2 dash is minus e to the power minus x. And x is this in our question. This is equation 10. This is step 1 is complete. Given question in our question paper, I am taking as equation 1, then writing in D form. Second point, after putting right hand side is 0, that is equation 3. If equation 3, then we convert in auxiliary form, putting D equal to m and removing y. Then we find roots of auxiliary form. Then we apply the formula for CF. Then we putting the roots of m. Then we find complete CF. That CF is equal to writing, considering CF, in general CF, C1 y1 plus C2 y2. C1 and C2 are arbitrary constant and y1 y2 are solutions. So we get after comparing, we get value of y1 and y2. We get two solutions. y1 is e to the power x and y2 is e to the power minus x. From our finding complementary function, we get solution y1 and y2. We get the value of y1 and y2. y1 is e to the power x and y2 is e to the power minus x. After differentiating these solutions, we get y1 dash and y2 dash. So y1 dash is e to the power x, no change, and y2 dash is minus e to the power minus x. And capital X is 2 upon 1 plus e to the power x from given in our question and right hand side. So now step 2. What is step 2? We apply second step, finding particular integral of 1. Putting C1 is arbitrary constant in our complementary function and C2 also arbitrary constant. So both arbitrary constant, C1 putting equal to U and C2 convert in V. C1 and C2 are constant, but UV are function of X. C1 y1 plus C2 y2 is complementary function. Then C1 convert U and C2 convert in B. Then U by 1 plus B by 2. This is the complement. This is the particular integral. By 1 is U e to the power X and by 2 is e to the power minus X. So this is U e to the power X plus B e to the power minus X. This is equation 11. Now finding value of U and B with the help of the following formulae. We are using here following formulae. This is for finding U, value of U. We can find this equation 12. What is U? Minus X y2 upon y1 y2 dash minus y2 y1 dash. But here I am putting X. X is 2 upon 1 plus e to the power X. This is X. And now y1 is e to the power X and y2 is e to the power minus X. And now y1 dash is e to the power X and y2 dash is minus e to the power minus X. These are values putting in this value U. And now step 4. Step 4, y is equal to complementary function plus particular integral. This is the complete solution. Complete solution of 1. Okay. Now we have following formula for finding U. So this is 12 equation. I am taking 12 formula here. So putting all value here. Putting X equal to this, Y1 is this and Y2 is this, Y1 dash and Y2 dash. All values putting in this formula. So here minus X, this is the X. And this is here Y2, my e to the power minus X. Upon, this is Y1 e to the power X, Y2 dash. Minus Y2, Y1 dash. Here this cancel to this, here this cancel to this. Okay. So this is minus 1 and this minus 1. So now here minus 2 upon 1 plus e to the power X, here e to the power minus X. And this cancel to this, e to the power X into e to the power minus X. This is e to the power X minus X, e to the power 0, this is 1. Okay. So this result 1 and this result 1. So I am writing here minus 1 and minus 1. Minus 1 and minus 1. So this result is minus 2 upon 1 plus e to the power. This is minus 2. Here is e to the power minus x dx. Now this is e to the power minus x dx upon this 2 is cancel here. So we get here minus 1. Okay. Minus is this also. So minus also cancel this. This minus cancel this minus 1. So here e to the power minus x, we can write e to the power minus x equal to 1 upon e to the power x. We can write this. So I am writing this in denominator. Dx upon e to the power x 1 plus e to the power x. Now here applying partial fraction. Apply partial fraction. Partial fraction. Partial fraction, then we can write 1 upon e to the power x minus 1 upon 1 plus e to the power x dx. Breaking this separate integrals. Integral e to the power x dx, e to the power x dx and minus 1 upon 1 plus e to the power x dx. So integration this e to the power x dx. Here is minus. This is minus this. And here is minus taking inside. This minus taking inside this minus and writing here plus. So this plus here minus e to the power minus x. E to the power minus x. Here is also e to the power minus x. So now here let 1 plus e to the power minus x equal to t. So 1 ka 0 plus here is minus e to the power minus x dx equal to dt. So this result convert in dt total. So this is this integral here minus e to the power minus x upon 1 plus e to the power minus x dx. So this result is dt. This is dt upon t. So this is log t. This is log 1 plus e to the power minus x. So this is integration this. Here is e to the power minus x, integration minus e to the power minus x plus log e to the power minus x, this. Okay. This is e to the power minus x. This is e to the power minus x. So this is some typing mistakes. Now here, we get here equation 15, b finding u here. Similarly, we can find value of v with the help of formula 13. And putting all value this, x is this, y1 and y2, y1 dash and y2 dash. All values putting in formula 13. Formula 13 is this. Now here integration y1 is e to the power x and x is 2 upon 1 plus e to the power x. Now y1 e to the power x, y2 dash minus e to the power minus x, minus y2 e to the power minus x and y1 dash is e to the power x. So this result is cancel this result is cancel this. This is minus 1 and this minus 1. So e to the power x upon 2 upon 1 plus e to the power x. This is minus 2. So I am writing here minus common 2 is cancel here. This 2 cancel this 2. So we get here e to the power x 1 upon 1 plus e to the power x dx. Now minus is common, e to the power x upon 1 plus e to the power x. So here for solving this, let 1 plus e to the power x equal to t again. So differentiating with respect to x, the 1 ka 0 plus e to the power x dx is equal to dt. So this is here dx, e to the power x dx is dt. So we can write here dt upon 1 plus ex is t. So this is log t. This is minus sign. So minus log t. Minus log t. T is 1 plus e to the power x. This is solution. This is the value of v. Okay. So now here we find the value of u and v. And y1 and y2 also already known. So here this is complete pi. Now complete particular integral of 1. This is u y1 and plus b y2. Y1 and y2 already known. U and v here we find out. Putting value of u. This is y1. Y1 is e to the power x. This is value of u. What is u? We have find here u. U is this minus e to the power x plus log 1 plus e to the power minus x. So putting value of u here, minus e to the power minus x plus log 1 plus e to the power minus x. Plus here y2 is e to the power minus x. E to the power minus x. And this is b. What is b? b log. What is b? We have find the value of b here. b is this minus log 1 plus e to the power x. E to the power x in bracket minus e to the power minus x plus log 1 plus e to the power minus x. This is y1 and this is y2. This is u. And plus this is y2 e to the power minus x and this is v. v is this minus log 1 plus e to the power x. Here is minus log 1 plus e to the power x. This is v. So this is y2 and this is v. So u y1 u plus y2 v. This is complete pi. This is complete pi. Complete particular integral. Okay. Now here complete solution of 1 y is equal to cf plus pi. Complete solution y is equal to cf plus particular integral pi. So by cf c1 e to the power x plus c2 e to the power minus x. This is cf complementary function. This is particular integral. What is particular integral? Here multiply by this minus x. E to the power x multiply by this. So after multiplying we get this result. Pi is equal to, here multiply minus 1. this cancel here. Multiply with this cancel here. And plus e to the power x log and 1 plus e to the power minus x. And here is minus e to the power minus x and into log 1 plus e to the power x. Okay. So this is pi. Now this value putting here. So now final answer is y is equal to c1 plus c1 e to the power x plus c2 e to the power minus x. This is cf. And plus pi. Here is minus 1 plus e to the power x and log 1 plus e to the power minus x. And plus here, next stage, here e to the power minus x minus e to the power minus x and log 1 plus e to the power x. Okay. This is complete solution. This is y is equal to, this is CF and plus this is PI. Okay. This problem solved with the help of variation of parameter. So in this line there is some mistake. So I am writing directly this solution. This is complementary function CF and this is particular integral. Here in V, we multiply by this e to the power x here and d to the power minus x to this function. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.